Today we're going to be looking at squares and square roots. Any whole number multiplied by itself produces a square number. Another name for a square number is a perfect square. 25 is an example of a perfect square because it can be evaluated by multiplying 5 times 5. So 5 times 5 is 25. So any whole number multiplied by itself is going to produce a square number here. So 4 times 4 is 16. 16 is a perfect square or a square number. You can see if I were to arrange 25 dots into a 5 by 5 grid, it makes a perfect square. So 5 times 5 is 25. The square root of a number is the value that when multiplied by itself gives that number back. So it's the opposite of finding the square number. It's going back in the opposite direction. So if I have 25 and I wanted to find the square root of 25, I could arrange them into a square, and the square root of 25 would be the side length of the square. So there are 5 dots on the side length, so the square root of 25 is 5. Another example I've got here, if I'm trying to find the square root of 16, this is a square root symbol, and it's saying I want to find the square root of 16. I want to find the number when multiplied by itself gives 16. So if I arrange 16 dots here, 16 dots into a square, I can see that the side length is 4 dots. So there's 4 dots along the side lengths. So that means that the square root of 16 is 4. And conversely, going in the opposite direction, 4 squared is 16. So I've got some examples here that we can go through, some squaring and square root questions. Firstly, we're looking at 6 squared. 6 squared is the same as 6 times 6, and that's 36. So 36 is a perfect square. To find the square root of 64, I need to think what number, when multiplied by itself, gives 64. And 8. 8 times 8 is 64. So the square root of 64 is 8. This one's a bit trickier. The square root of 1,600. So that's exactly the same as the square root of 16 times the square root of 100, because 16 times 100 is 1,600. So I can evaluate those individually and then multiply them together. So the square root of 16 is 4, because 4 times 4 is 16, and the square root of 100 is 10, because 10 times 10 is 100. So multiplying those together, we get 40. So the square root of 1,600 is 40. That means 40 times 40 is 1,600. Here we've got an order of operations problem that has a square root and some square numbers involved. So because we've got a square root of not just one number, it's of a whole lot of numbers, we need to determine what the number is that's going to be inside the square root here. So 8 squared I know is 64, and 6 squared is 36. So 64 plus 36 means we're going to have 100 inside the square root symbol there. Notice I haven't changed anything with the 3 squared. We're not going to evaluate that just yet because we've got an addition sign here. That's down the bottom of our order of operations hierarchy, so we can leave that right until the end. The square root of 100 I can determine though, because we know that 10 times 10 is 100, so the square root of 100 is 10. 3 squared is 3 times 3, so 3 times 3 is 9. 9 plus 10 then, doing our final evaluation, is 19. So you might see, whenever you see 3 squared, it might be said as 3 squared, or it might be said as 3 to the power of 2. They're both exactly the same thing. It means 3 times 3 and will result in a square number.